to describe the distribution of data on visual displays. This is only for quantitative data. Qualitative, you can look at that and say, most frequent, least frequent, category, make a comparison. We've been kind of over that. For quantitative, when you look at a graph, and I'm going to show you some examples, you need to talk about spread, outliers, center, and shape. And we have adopted this acronym of SOX, and I think it's helpful for people to remember, as long as you can remember what the two S's are: spread, outlier, center, and shape. And so spread is referring to whether the graph is like spread out as a wide range or a small range. Is it squished together, or is it like spread out flat? I'm going to show you some examples of that. Outliers: is there any data element that sticks out as unusual? Is there any behavior that seems to be like not as frequent? Center: this is mean, median, or mode, and I need you to report them appropriately. So pick the one that you should report based on what you've learned. And you may estimate, if you're just given a graph and it says describe the distribution, you can even give a range and say, oh, the median is between here and here. And then shape, you're just going to talk about two things: whether this is skewed distribution or whether it is more symmetric. And these aren't going to be really cut and dry. So if you're describing them in writing, set yourself up with like a nice paragraph, right? And just say like, well, this shape would be considered more skewed because of this reason. And I think that providing a rationale will also help you in these cases. So let's just talk through a few of these things here. The first thing, can I move that? Let's put that up there. Okay, so it's an age distribution. It looks like they surveyed what's your age? How old are you? How old are you? How old are you? And they had a range from between 8 years old and 17 years old. And if you kind of think about this is just a frequency polygon. So you could think of this as maybe like a histogram or something like that. But without the bars, you just show like the general shape. So this is a very symmetric shape. You don't see on any side, we don't see like a crazy behavior to like the high end. We don't see crazy behavior to the low end. So just making sure that you're looking, literally, if you folded this graph in half, it would be symmetric. So here's the things you would say, right? All right, spread. The range of the data goes from 8 years old to 17 years old. Okay. You don't have to comment to whether that's really spread out or not spread out. But if you think about human ages, you can say like, obviously this just incorporates a very small, from 8 to 17 years old is a small portion of a human life. So you can totally say that's not very spread out. 2, outliers. So S for spread. We talked about that. Outliers. I don't see any atypical behavior on this. So if you think that there are no outliers, then oftentimes that's going to be tied into some of the other things that you're saying. When you're looking at the center, so we did spread, outlier, center. The center behavior here is more about frequency. So most of the people we surveyed were what age? And when you look at that, you're going to say, okay, well, around 85 people are age 12. So you could say typically the people that were surveyed were between about 11 and 13, or even like 10 and 14 years old. You can give me like, what is the most typical behavior? So it's like 12-ish, right? Can you just say 12? And then shape, which is symmetric. We talked about that. So you are just giving like a little overview. I don't want you guys to think this is like crazy. You have to write a novel. Like, please don't write a novel. But when you're discussing data, you have to be able to talk about those 4 things in general. Let's look at the next one. Another one. Okay. Frequency polygon for reported violent crime in American cities. This is the frequency of reports. Right off the bat, you could see like symmetrical, not symmetric. Okay, so let's go in order. Spread. Okay, reports of violent crime go from 0 to 10,000. Okay, that is a spread out situation, okay, which is tied right in with O, which is an outlier situation because, yeah, we have, yes, it's crazy, right? So you look at 7,000 or above, even 5,000 or above, that is not a lot of data. There's 5 cities almost that report 6,000 reports of violent crime. We don't even know if this is like in a year or what. This is, or total. It seems like total. Like, that's crazy. What does that even mean, violent crime? So forget that we didn't operationally define any of that. We're seeing that these dots are very low on the right side of this graph. And so you're saying, okay, the spread, this is really spread out from 0 to 10,000 reports in whatever time period, whatever that means. If some people are reporting 1,000-ish and some people are reporting 10,000-ish, I think that's like definitely spread out. So we're going to say that. 2, tied in with that, outliers. You could say that there's 6,000 or above is atypical, or 7,000 or above is atypical behavior for this set. Obviously, most of the data is clustered lower, and so we have outlying behavior here, which is fine. We have to take it into consideration. You don't just want to leave it out. The center behavior here is so critically important because you're not just looking at like the middle of what you think the graph is. You can't just look at the middle of the x-axis. You have to look at the middle central behavior of the data. Where is most of the data clustered? Most of the data is clustered to the left. So in between 0 and 3,000. So you're going to see the data wants to live between 0 and 3,000. We have this outlier behavior past that. So therefore, our center behavior is going to be pretty low. We want to go with our median. This is outlier behavior. So don't report the mean to me on this. You're going to report the median. And you can estimate, right? So, or you can count them up and estimate, but just report it, find it, report it, okay? And then shape, this is skewed. This is not symmetric. This is skewed. And in this case, it's going to be skewed right because that's where the outliers are, but it's going to be enough for you for right now to just say skew. Recap, SOCS, right? Like this. So left to right. Let's do spread, super spread out because we go from 0 to 10,000 and we want to just kind of talk about the range. Totally great. So 0 to 10,000 at the range is spread because of the outliers, which are contributing past about, that's debatable, but I would say even past 3,000. Like you could say past 3,000, upwards of 7,000. Discuss the outliers in relation to how spread out this is. Center behavior, discuss the outliers in the center behavior. The center behavior should be reported as the median, estimated median. And you could even say that. So even if you can't estimate off the graph, you could say the median will be a better measure of center than the mean because of the spread and the outlier situation. Because of the spread, because of the outliers, and because of the skewed mean, then we have a skewed distribution. So it's not symmetric. SOCS. Let's look at another one. Let me find a good one. I might go back. Let's just talk about the shape. Let's talk about one thing. The skewed. Let's look at this one again. But these are similar. So if you're struggling with this one, take a look at this one. And what I said was kind of the same. If you were struggling with this one, take a look at number 4. It's pretty much about the same. All right, let's look at this. This is weird. Okay, you might not have seen this. It might not be. Just focus on the visuals here. Okay, which one of these graphs is more spread out? The new golf ball is more spread out. It's wider. Literally just look at the range. In fact, this box is more spread out as well. So you can compare that as well. Neither one seem to have outlier behaviors. If one of the whiskers was like here, like super, super long to the left, then you would say that these are outliers. But in this case, no. This is pretty typical. We don't have any outlying behavior. Center behavior, you can comment and say that the current golf ball actually has a very, very slightly higher median or center, which is this line here. And then shape, this is obviously more symmetric, but both of them are kind of, on the symmetric side. All right, for this one, we can say that the range, we have our four things, right? So spread, this is pretty spread out. It says there was an easy exam here, and this has to be in context. Just I keep forgetting to say that, but like it might sound like I'm saying the same things over and over again, but it has to be about the context of the graph. This was an easy exam. Easy exam. It was pretty spread out for an easy exam. Okay, so I'm going to say this is pretty spread out. You're going to tell me the range is almost 60 points. You don't want, as a teacher, an easy exam to have a range of 60 points. No, ma'am. Mm-mm. Okay, so spread, super spread out because of outliers, because there are two outliers, okay, and they're marked here with these two symbols, okay. So very spread out because there are two outliers. The center behavior, though, is very, very high. So we want to report the median, which is over 90%. These two outliers and like the rest of this tail is going to seriously skew the mean. Our mean will look lower. Our center behavior as a mean will look lower. So we want to focus on the median here. These outliers, I'm a teacher. I'm going to see, look, half of my kids did better. Over half my kids did better than a 90. We need to definitely mention that for the center behavior, right? And then for shape, this is skewed. Okay, so if there are outliers, this is skewed toward the outliers, skewed left. We don't have to worry about that right now. So if I said write down what you know, what's the distribution of this graph, you are going to say, this is an easy exam according to the title. That is a very spread out range. That is, the scores cross almost 60 percentage points due to the fact that there are two outliers that are marked on the graph. They bring the mean down, which means that you should report the median, which is over 90%. And then the shape, because of the outliers, all of these things lead to the fact that the shape is skewed because of the outliers.